This lesson we're going to learn some properties of logs, and the first one we're going to learn is very useful for evaluating logs that we can't evaluate exactly, that we'll need a decimal approximation for. Since our calculators only know the common log, or base 10, and the natural log, base e, if we need to evaluate a log with any other base that doesn't work out exactly, we're going to use this change of base formula. So here's how I remember it. First of all, we're changing it to a base that is useful. Typically, we're going to use the common log or natural log, so that will be our b. When we look at the log we're given, a is lower than x, so a goes in the denominator, x will go in the numerator because it's higher. As I mentioned, today we're going to be looking at properties of logs to expand log expressions as well as evaluate logs. Starting off with our change of base, we cannot evaluate log base 4 of 30 exactly. 30 is not a power of 4. So we will do log of 30, our common log, so we can punch that in our calculator, over log of 4. Again, in the original log, 30 is higher than 4, so 30 goes in the numerator and 4 goes in the denominator. When you use your calculator to evaluate this, you get about 2.453. Second one, we'll use the natural log 4. So we'll change this to natural log of 14, which is higher than the 2 in the original question. And again, just punch this into your calculator, and we get about 3.807. The one thing that you really need to remember with change of base is that you are changing it to the same base. So you can use either common log or natural log. You may not combine them. Also, some of your calculators do have a log-based function where you don't even need to use change of base in order to evaluate. So we can take a look at that in class as well. Here we have some properties of logs, and I'm not going to go through the proofs of these with you like I did with the exponential ones because they're much more complicated, but I will try and link them back to the exponential properties to try and help you remember them. So our first one, remember the answer of a log is a power. So if we are adding two powers together, it came from multiplication. So this came from the rule, if we are multiplying powers, we add the exponents. Our second rule comes from the division property of exponents. If we subtract the exponents, it came from division. So this would be something like x to the 5th divided by x squared, and we subtract those exponents. Our last one comes from the power of a power rule. If we have a power raised to a power, we multiply the exponents together. A log is an exponent, so we're taking this exponent times what was an exponent in the problem. We're going to use these properties to expand log expressions. Starting off, I noticed that I have log of multiplication. We expand that to addition of logs. So it becomes log base 4 of 5 plus something else needs to change as well. We can't just change the multiplying to adding. So the other thing we change is adding in extra logs. So log base 4 of x cubed plus adding in another log base 4 of y. That takes care of the multiplication. If you look at that second log base 4 of x cubed, we have a power, so we're going to use our power rule. Our log base 4 of 5 is simplified. We're going to bring the power out front as a coefficient and multiply it by log base 4 of x, and our log base 4 of y is simplified as well. This next one appears to be simplified. We don't have division, we don't have multiplication, and we don't see a power. However, remember that the square root is a 1/2 power. So we can use our power rule, make that 1/2 a coefficient. This next one, we have a power from the root and division. So we're going to start by rewriting this as x to the 1/4 power over y to the 1/4 power. We're going to split up that root and change it to a power so that we don't lose the fact that that 1/4 is going to go on both logs when we split this up. Next, we'll split it up using our division rule, which means we will subtract, again, add in that extra log, And finally, we'll use our power rule, bring those powers down as coefficients. Our final rule, I'll start by splitting up that multiplication in the numerator. So we get log of x to the 4th plus log of y to the 7th. And then we had division, so we will subtract log of z squared. And then we'll use our power rule, 4 times log of x plus 7 times log of y minus 2 times log of z. You will know your expressions are fully expanded when you have log of a single term with no powers. So you should have no multiplication, no division, and no powers left in the expression that you're taking the log of. Here are a couple of U-Try questions for you to practice. Please make sure you bring your questions to class so we can start our time productively.